Start recording. Okay. Hello, everyone, and welcome to Handmade Hero. We're coming in a little bit hot today because I just got through ranting about people who are sort of asking about libraries and why you don't use them. And I just kind of totally dumped on libraries for about 10 minutes. So, you know, there's a little bit of furor in there. There's a little bit of, like, fire in the belly. It's true. But we are going to channel that into coding, hopefully. We'll see how it goes. Anyway, welcome. On that note, welcome to Handmade Hero, the show where we code a complete game live on Twitch. No libraries, which is kind of the point of the pre-stream. No libraries whatsoever. I think the only thing we're linking with right now is the C runtime library, which honestly I think eventually we'll probably want to remove as well, because why not? Once you're not linking with any libraries, you might as well not let the one default library stand in your way from actually being able to say you link with zero, because there's not that much work to remove it, right? But anyway, separate from that, welcome to Handmade Hero. Today we have to do some work on something that's kind of the bane of the existence of 2D games that want to do some 3D effects, which is handling that extra Z layer. And the reason for that, of course, is because, well, the art isn't 3D, right? The art is little bitmaps, and you're constantly in this thing of like, how do I take little bitmaps and turn them into something that sort of fakes some of the effects of 3D without essentially fighting the fact that it is bitmap art. And again, we could just ignore this problem altogether and just have the game take place on a flat plane where you can never see anything above or below you. And that is what a lot of 2D games do. But again, because this is a programming stream, not a stream about getting a game done as soon as possible, we have chosen to try and handle Z in a number of ways just so we can explore the complexities that come with it. And, you know, just so you can watch me wrestle with them, because it's not a case where there's any perfect solution. And so I think, again, I try to introduce things into the stream that I'll have to struggle with and weigh decisions and not just see an immediate answer and go, oh, well, we just typed it in and it worked, right? Which you kind of see happen, like, for example, when we did texture mapping, we just kind of typed it in and it just worked. It was like, you know, 15 minutes on the stream after explaining it on the blackboard and it just works, right? Known things like that are pretty easy, but they don't really teach you about how to work through difficult programming problems where you're trying to do something that doesn't have a necessarily right answer. And this is one of those things. And so we're in the middle of that process of trying to work through it, trying to look at exactly what we can do to get some amount of clean rendered or design that still brings out some of that Z depth to the game. So that's what we're doing today. We're going to start some of that exploration process because we sort of set ourselves up to do that based on what we did yesterday. And today is day 107, so if you'd like to follow along at home and you pre-order the game on handmadehero.org, what you want to do is take that source zip file you can download and you want to unpack day 106, because that was yesterday's code. That's what we're starting with today to make today's code. All right, so let's get going. Let us get going here. That is, if I could actually remember how to load some code and compile it, which is kind of what we need to do. So, all right, where we left things off was we had sort of made we had like a little test world here we were working with that actually had two Z layers on it. You can sort of see that the way that they go here. But at the moment we have a number of things that we're not really doing. Like, first of all, we turned off rendering of our ground chunks, which I would like to turn back on. And what I'd like to do is start to get a notion of those Z slices in here, because we don't have that at the moment either. We can also kind of do something where we pan up and down. You can kind of see what happens there if I move the camera in and out a little bit. But again, we haven't really done much in terms of dealing with these Z slices other than just handling that offset, right? So I think the first thing that we want to do is really kind of go in there and take a look at how to get those Z slices in there. And you can see the trees kind of moving at different rates. There's one ring of trees that's above and one ring of trees below. But until we put the ground in there, it's going to be hard to really visually understand these things. So let's go ahead and do that and maybe just start to try and get those ground slices in place. Okay. So what we decided, and this may be a fairly lengthy set of changes that we want to make here, because remember, we've got a lot of things in play now, and we're trying to solidify the Z across all of them, right? And so if you remember, we've got our sim region, which is the thing that handles basically computing how entities update over time. We have our handmade world structure, which basically packs entities into their locations, like where they are and that sort of stuff. And what I want to take a look at here is previously we had this world position stuff, and we have the chunk Z, this sort of Z conceptualization of where things are in Z. And what I'd like to do is I'd like to start getting, start talking about that Z in terms of actual slices in the world that probably coincide with the chunk Z, so that we can talk about them in terms of layers. Because what we keep seeing when we work through this is really we need this concept of fixed chunks of Z, because since the bitmaps themselves can't encode really much 3D information, we need a way of sort of saying, well, everything at this level we'll just assume kind of works all together, and everything at the next level up works all together, right? And we can't really allow things to cross between those two, to exist in both of those at the same time, because the bitmaps would have to like shear and stuff in order to maintain the perspective and do all sorts of things that we really can't do with the art style that we have. And so in order to get around that, what we're trying to do here is we're trying to make a world that essentially exists coherently in terms of slices, and entities can move between the slices just fine, but in general the slices of the world in Z should be essentially separate. They shouldn't be trying to have art extend between them. If there's things that need to go between them, there's art on both of the levels, and we just accept the fact that there might be some breakage there just as part of the way the art style works. That's just how it's going to work, right? That's what we're doing. And if we find that that breakage is too off-putting, what we'll do at the end is instead of, we can just turn off that scaling, and that will make all of our levels line up, and then we can have the art kind of just line up with tops and bottoms if that's what we want. But I suspect, since the game is not really about having these tall structures or anything like that, I suspect that what we'll be able to do is basically just treat things like a series of shelves, and we really won't have any problem with it. And of course we can have lots of entities that move between them without really having any problem, so that should be totally fine. So that's where we're at. And so I want to start thinking about this in terms of where everything is and trying to start working through that chunk stuff. So let's take a look, first of all, how our sim region stuff handles unpacking entities. I just want to kind of go through this quickly. So basically what happens when we unpack entities, I don't really want to be in move entity here. I want to be in the sim region stuff that actually unpacks. Which is begin sim. There it is. So in begin sim, what we do is we loop over all of the chunks that are hit by the camera, right? And we go ahead and pull out all the entities, and we add them to our sim region, and then when we're done, right, we stuff them all back in. And that is pretty agnostic about what's happening with the chunk Z. And you can see here that what generally happens is we maintain the chunk Z, but we don't, excuse me, we maintain the chunk Z for the camera, but we never actually do, for the offset Z, we never actually use that offset Z. So you can kind of see here, we even do it, we even make sure that we preserve that Z. So the camera doesn't move up and down smoothly at the moment. The camera like hops between levels. And I don't know if that's the way we want it to do. Probably that's not what we want it to do in the end. We probably want it to kind of move cleanly between them. And so this again also gets back to sort of the concept of the ground and where the ground should be. But let's hold off on that for a second. So what I want to do is I want to go back in here, and I'm going to take out that cam offset Z that we were playing with a little bit there that I just kind of threw in there for a second. Offset. I don't know if you remember this, Z offset. I'm just going to get rid of that real quick. So that's gone. I'm going to get rid of all this stuff. There we go. And got Z offset here. Ground entity point, rid of that. And we've got, okay. So I think that's all of that. So now if I run things here, we're just doing the same thing that we were doing before. Everything's good. And remember, we've got our sort of hidden, I guess this is because we haven't turned our rectangle code back on, so I should probably go in here and see if I can get our rectangle code back working, because we kind of forgot to ever re-enable that when we were working on scaling and stuff. Let's see if we can turn our rectangle code back on. As you can see here, we've got draw rectangle slowly, working in our coordinate system. Let's see here, draw rectangle, oops, there we go. Draw rectangle. So if I turn that back on, I'm not sure what the status is of our rectangle code. It looks like our rectangle code is all correct. So we had actually updated it properly. We just left it turned off, and so that's fine. You can see those room boundaries still there in blue, and that's all good, right? So there's that magical stairwell that we still don't have art for, and you can see as I walk up it, we get to the upper layer, right? Everything seems perfectly kosher with that, but we do have that Z chunk snapping, right? That Z chunk snapping. So what I want to do is see if we can just turn off the Z chunk snapping and get us into a sort of a continuous movement for the camera there. So let's take a look at NSIM again. And so here's why that's happening, right? You can see that we take the chunk Z of the camera, but we don't really ever do anything with the offset. We sort of preserve that offset. So if we wanted to, we could probably do something like this, where we just go ahead and leave that offset, don't try to restore that offset, and let the offset become set based on the camera Z. And if we do that, I suspect we will have, there you go, there's a continuous movement in Z. You can kind of see that working there. And that looks pretty good to me. I think that's the way we would want it to work, right? Where things kind of fade in and out. That top layer fades in as I move up and down, like so. And so that's all good. But what we need to do now is we need to sort of introduce that coherent concept, because what we'd like to do, again, like I was saying, is we want to fade these, I was saying this yesterday, we want to fade out that top level, because if you think about it, there's going to be ground in here. There's going to be like actual ground and stuff tiles. So if we were down here, all the ground would be obscuring our view. We wouldn't be able to see anything, right? So what we need to do is get rid of all of these things that we're drawing up here. We don't want any of those to draw until we actually start to move up. And then when we move up, they should sort of fade in, right? We kind of all agree that that's what's supposed to happen. We've talked about this on the stream multiple times. Everyone seems pretty happy with that as a plan. So the question is, how do we do that? Well, the first thing that we need to do is we need to have some conception of basically these Z slices. Because what I need to do is I need to know where I am relative to the slices. And so what I want to do is introduce that concept and say that we have fixed Z slices in the world, and that world structure, again, this world structure here, I want this to be like a definitive reference, right? I don't want everything in the code to sort of have its willy-nilly, where's the ground, what level is what, and all that sort of stuff. We want to get rid of that concept. Not necessarily for collision detection, like maybe we want to have different heights of things that you can hop on. I don't know if we want to do that or not. I'm just saying if that was the sort of thing we want to do, that's a separate thing. What I'm talking about is the actual concept of where the base ground level is going to be in these slices. And so what I want to do is have the world structure be able to answer your question for this point in space. What is the ground level that would be below it or on it, right, if it's standing on it? And what would be the one above it and below it, right? So you can kind of get this opinion of where you are in that space, right? And so I want this query that I can basically say, hey world, here's where my guy is. I need you to go ahead and tell me kind of what that strata is, right? And that way we're free to modify the way that that's working in the future. We're even free to have different parts of the world think about it differently if we really need to later. I don't really want to do that because I feel like that's probably unnecessary, but if we had to, like we had a special area that needed to be treated in a sort of a special way, we could have the world answer those queries using kind of some kind of special stuff, and everyone that was asking would be able to still work without having to know that there were special areas of the world that have that sort of different stuff to them. All right. By the way, in case everyone's wondering, I'm drinking strawberries in agua fresca, basically, like a strawberry agua fresca today. It's not soy milk. All right. Let's do this. So here's my world struct, and here's what I want to do. So we have that global alpha value, which I said was weak sauce, but we're going to use it just for now to make sure that we kind of get things working with the global alpha value. And then what we'll do is we'll pull out the global alpha value, and we'll put in a render target thing that will allow us to do it in proper fading slices, like I said, what we wanted to do before. Okay, so what we want to do here is go, all right, we've got this global alpha, and so what we want to do when we come through here and we're rendering these entities, right? What I want to do is I want to be able to, in fact, I guess now that I think about it, I don't even really need the global alpha to do this for the most part, do I? Because each individual entity, I'm just going to be able to see when I go to render the entity, I'm going to set its alpha value to be something sort of to what's the word I'm looking for? I can set its alpha value to be based on where it is, right? Based on how high up it is. And in fact, I guess this global alpha here, right, what I could do is just move it down so that every entity, we can still lean on that global alpha system. And what we'll do is every entity will use its position here to kind of determine that. Now we have a little bit of a jankiness, and this probably gets into something we want to talk about a little later, which is that we don't actually know the final resting place of the entity because we haven't simulated forwards yet. And I think this is arguing towards wanting to separate out the render past the sort of the render from the update, which was something I didn't want to do prematurely, but we're going to talk about that in a bit. To do, Casey, probably indicates we want to separate update and render for entities sometime soon. And again, so that was something that we talked about before. And again, like I said, one of the reasons that we put update and render together as one pass, architecturally speaking, is so that some things can update and render together if it's more efficient, and other things don't have to, right? And so I guess this is sort of what what you will probably be seeing here is I think we'll probably break entities up so that they update and render in separate stages. And that's the kind of flexibility you want to have, right? So if we have other things like particle systems, maybe they update and render together because it's more efficient that way. Whereas entities, it's because of the way that we're working with them, we want more flexibility. We can separate it in two passes. And again, that's a really important thing. I think it's good to always have update and render be together and then only break them apart when you see that you have a clear reason for doing so. And then you'll get some efficiency there or something in return. Whereas everything else you want to leave updating and rendering together so that you don't basically spend all this time pulling things in and out of the cache for no reason, just to operate on them in two passes that didn't actually need to happen, right? But anyway, again, that's something we can take a look at a little bit later on. For now, we don't care. We can just use one frame of lag in terms of updating the alpha. Doesn't matter. We can deal with that in a little bit. So anyway, we've got the global alpha, and what I want to do is I want to set the global alpha based on that position. So the first thing I'm going to do is I'm just do this in line here, and then I'm going to move it out into a query in the world to get that out so that it has the properties that I was saying were desirable there. So the way that I'm going to do that is I'm first going to take a look at where the entity actually is, right? And you can see that this right here, actually, this global alpha stuff, I should probably set just quickly in here. Although I think global alpha is automatically set to 1 in there, if I'm not very much mistaken. Let me just double check. Do we set global alpha to 1? Yes, we do. So we don't need to do it up there. So what we want to do is here in the sim region, you can see that we're going to start off where we're updating the entities. Now, so what we have is we have that entity position. What I'd like to do is figure out where that entity is going to be. Right, and you can kind of see us doing it down here where we do get ground entity ground point. I'm going to call that get ground point function. I'm going to use that entity ground point to determine what the alpha value for this entity should be and set it here. So when we call that get entity ground point like so, I'm also going to make sure we clear the global alpha here. You can see this global alpha is annoying to work with. That's why I say I don't really want this as an actual feature. We're just kind of using it now. I don't like things that you set globally and then have to remember to clear and all that. It gets a little bit janky. So, that's kind of why I say this is not a feature that should stay in there. We're just using it for now. So kind of keep that in the back of your head. Anything you see me doing in this global alpha, this is just for test code. We don't want to keep this in the render long term, I don't think. Anyway. So when we get that ground entity point out, so we'll get that, we'll just call this ground P for now. What I want to do is I want to set that global alpha based on the ground P. So what I need to do is I need to figure out how far away from the camera it is, right? So when I have that ground P, and we should know kind of where the camera is as well, because we know that the camera is at camera P, right? And so what I want to do is I want to figure out what the difference between those two things actually is. And I believe since the camera is always at the center of the sim region, technically I think we can always just assume that, right? I mean, am I totally off here? Let me see if we've got that or not. It looks like we don't really say where the camera is in here. And I wonder if that's a little bit of a mistake because the sim, oh, sorry, that's the sim entity. I wonder if that's a little bit of a mistake because I feel like we should say where the camera should be in case we want it to not be at the origin. You know what I mean? It seems like that's something we would probably want to think about at least a little bit, right? You see where I'm going with that. I feel like I'm going to go ahead and try to introduce that here. I feel like we want just a camera position, like camera position relative or something like that, that says where the camera is or something like this, right? Note, this is the camera position relative to the origin of this region. Just so we can kind of figure out where the camera is, where the camera is supposed to be. Because, maybe we've got the sim region offset somehow from the camera in some way. We want to be able to still know where the camera position is, right? And so when we go to render, we want that camera position to be in the center, right? And so what we want to do is displace all the entities by whatever its negative is, right? So basically, I'm going to introduce this camera position. When we do begin sim, right now we're always assuming that the camera is at the center, but in the future maybe we'll assume something else. And so when we do this here, when we do all of our sim stuff, and then we go ahead and we add entities in here, right, and we try to compute their position, we do get sim space p, and in here we have all that stuff. What I want to do is just figure out where the camera should be, and for now I guess we'll just assume that the camera is actually nowhere, right? It's just, that is actually just already at the center, right? So the sim region, oh, and you know what, that'll already be done for us actually, but I'm going to put it in here just so we remember, and I'll put a to-do, Casey, some way of specifying what the camera position, right, should be, or something like that. Oh, you know what? Now that I think about it, that's actually kind of dumb. I don't know that we really need that because only the render pass is ever going to care about where the camera is probably. So maybe we should just have that happen in here, right? We know that the camera position is going to be relative to the sim region that we opened. We can just compute where it is directly. In fact, we've got the ability to do that, right? So we can go ahead and say, oh, the camera position, that's just going to subtract wherever the camera was from wherever the sim region was, right? So it's really just going to be something like this, world position sim center p, like that. So there we go, sim center p. And then we'll always just say, well, that's the camera position, right? Something like this. Make sense? Oops, that's game state. And that way, now we know that we're actually handling it. This is just going to produce 0 because it's going to be camera p, subtracted from itself. It's going to produce 0. But at least now we would always know. Do we have the world here? Yeah. At least now we'll always know that if we want to adjust the location of the sim center, we can and nothing will break, right? So that's what I wanted to do there. So what we can do is like say, okay, camera relative, what's the camera relative ground p of this thing? The camera relative ground p of this thing is going to be whatever the ground point is minus wherever the camera is, and then we can get that global alpha by taking the z value of this. That's how high, right, this is off of the camera. And what we can say is, well, we would like to use some kind of a function. Obviously, we want to clamp it between 0 and 1. We want to use some kind of a function that will produce that alpha fade, right? And so what we can do is we can say, we've got the relative ground p. We know that if it's 0 or negative, it's below us, right? So basically, that's, we don't want to do anything there. So we'd probably do something like saying, okay, if it's 0 or negative, it gets it's fine. And then what we want to do is sort of, when we have that z value, we want to pick some distance above which it will sort of fade out over time. So I'll maybe do it something like that. So we'll say 1.5 meters above the camera, something like this. Let's take a look and see how that goes. Let's see here. There we go. So you can kind of see how that fades in, right? You can see as we move upwards, we get that nice fade in effect, and it all kind of looks relatively solid, right? So I walk down the stairs, it fades out. I walk up the stairs, it fades in, right? Out, in, out, right? And so that's, that's relatively what we're close to what we're going for, right? And what you can see here is that I've done this in kind of an ad hoc way. And so what I want to do is I want to make this a little more formal, just so we can start to base it off of real values. So the first value, the way that I'm going to do this is I'm going to say, okay, what is how should I say this? I want to sort of say we've got these z slices, and the z slices need to fade in. So what I want to do is say, where do they start fading in and where do they stop fading in, right? And so what I want to do is like fade start z and fade end z, right? And so obviously the fade end, I want to say, and just to give you, in fact, you know what? Let me do this on the blackboard just so everyone's clear on what I'm talking about here. I don't want there to be any confusion about what's going on. What day are we? We're day 107. So here we go. Day 107. Here we go. So what we want to do here is we want to, excuse me, we want to parameterize this in some way where we can go, all right, we've got the camera, and at some level between the camera and our fade start, let's call this, everything is fully visible, right? This is visible. Then at some level between there, in the range between that start and the end, this is going to fade, right? And then everything up here is invisible, right? Make sense? That's what we want to do. And furthermore, we probably also want to do something that's like, okay, we've got, another thing here. So we probably want like fade start, this is like the top one. And this is like fade start bottom and fade end bottom. You know what I'm saying? So that we've kind of got in here a fade as well. And then, everything in here is invisible. So really this visible region actually is this whole range, right? And so what we can do there is we can actually, we could, if we knew that they were going to be the same heights, we could take the absolute value of whatever, but I don't think we want them to be, because I suspect that this is going to be smaller than this, right? And the reason for that is we may want, when you're looking down on something, the reason that we want to fade out these guys is because we don't want them to obscure your view. So we need the very first level. If we looked here at what the levels were, here's the one, here's the current ground that you're standing on, that the fade out start and top, this is actually where the next level would be, right? Here's where upstairs is, right? Because it should be invisible most of the time. Until you start walking upstairs, we shouldn't see it, right? But we actually want several levels of ground visible here, probably, right? So we probably want this to be very different values. We want this to encompass, like, say, this guy, right? So these are not going to be the same ranges, and I think we need to sort of appreciate that. So what we need to do is take wherever stuff is, map it into here, and then produce the correct fade values as a result, right? So what we want to do is say that we've got sort of a fade top start and a fade top end, right? And I'll stack these in the way that they actually stack. So then a bottom start Z and a fade bottom end Z, like so, right? That's what we want to see happen. And so what we can do here is say, all right, it's going to start fading in. Let's say it's going to start fading in a meter above the guy or whatever. And then it's going to stop fading at a meter and 0.25 or something like that. I don't know. I'm making this up. Maybe 1.5. I don't know. What did we even say? I don't even remember what we were sort of saying as our world thing. at this point. I don't even remember where we landed on that. We had set it when we create the world. When we create worlds, we had set the like height value in here somewhere. Where I don't even know where it is. I don't even remember this code at all. There it is, initialize world. So chunk dim in meters gets passed in, and so basically somewhere in here we were specifying it. Been a long time. So world chunk dim in meters is here. So typical game state, typical floor height, right? So what we probably want to do is say, okay, the fade, you know, that fade ends probably at that typical floor height above, right? So like so, right? So anything that's at the floor above us is gone. You can't see it. And the fade top end is probably, you know, as it kind of starts to fade in, I don't know, is some amount above that of the typical floor height. So it's probably, you know, it's probably something like the typical floor height plus some percentage of the typical floor height. Like a quarter of the floor height is how long it takes to blend something in, right? And then the fade bottom start, you know, that's going to be probably the negative, maybe it's 2 floors down, something like that. Everything becomes invisible, seems, or starts to become invisible. And then similarly, you know, this would be something, and we could write this a little, you know, we could accept the fact that we're all comfortable with math here and just do that, right? And then down here, it's like something like this, right? And so then I guess basically what we want to do is we want to do an if here to figure out if you're above top z or below bottom z, right? So we could say that your alpha is going to be 1.0, and then we'll just say, all right, if your relative z here, right? If your relative z is greater than fade top start z, then you're fading out on the top, and otherwise, if the camera relative ground point z is less than fade bottom start z, then you're fading out on the bottom, okay? And we're going to set your alpha accordingly. And what I'd like to do here is I'd like to just introduce a function. I don't think we've made one yet, right? At least I don't know if we have or not. I'll be honest with you. I forget what we've done in math and what we haven't done in math. This is the consequence of doing Handmade Hero as an hour a day and having it have nothing to do with what I'm doing at work. All right, so what I want to do here is I want to introduce a range function that we can use. I want to introduce something that's like, you know, clamp map to range or something like that. And what I want to do is say there's a min, there's a t value, and there's a max. And I want you to basically produce a value, a 0 to 1 value, that's going to tell me where t falls between min and max. It's like a barycentrifier, right? And you can see right now we got the clamp, we just don't have the divide. So essentially all we would need to do is call clamp and then divide by the range, right? So we've got the range here, it's just the max minus the min. That's how, you know, big the thing is. And really then all we'd have to do is say that our result is going, you know, we should probably check for 0. So assuming that the range is greater than 0, we'll assume that the result is 0 otherwise. If the range is greater than 0, then what we'll do is we'll go ahead and do a clamp 0 to 1 of whatever that t value is divided by the range, right? So that's essentially going to normalize the t value out to being in between the max and the min there, right? Oh, and I guess I gotta subtract the min from it, right? So this bases me around the min. As I go from the min to the max, I'll be producing values between min and max, right? I'm sorry, between 0 and range, and divide by the range changes it into a 0, 1, right? There we go. And so now all I have to do is like do clamp 0, 1 map to range, and what that allows me to do is just specify the min, the t, and the max, and we know what those are, right? So we just know that we've got the top value, we've got that camera relative ground pz, and we've got the fade top nz. There we go, and here we do the same thing. It'll start at fade bottom start z, and it will end at fade bottom end z. I believe that should do it. Now this range goes the other way, but I think that should be okay because it just means that the range will be negative, which will invert the sense of this divide, which I think is fine. And so I think that that should give us, roughly what we want there. We'll find out, certainly. So it looks like we set our value perhaps a little bit too high because those aren't faded out yet. Either that or I've made some egregious error. Let's see. So if fade start Z is a typical floor height above, does that actually mean that these things are unaligned in some way? It looks like they are. We'll have to work on that in a second. And it looks like our fade is going the wrong way. Why is that the case? Top start Z is the min, and this is the max. Oh, right. So I forgot, though, this is the alpha, so we want it to basically be higher as it gets. We want the inverted sense of this. So I could do 1 minus, which is a little bit more easy to read, right? Or I can flip these two to basically give it the inverse sense of the mapping, right? I don't know which of those is... Like, that's just harder to read if you do it that way, so I don't know that that's great. You know what I mean? I don't know if that's necessarily what we want, but yeah. Again, still got a bug in there though. Why do I have a bug in there? Okay, no, I'm wrong. I can't do that because that will produce a negative value, right? Which we don't actually want. Never mind. So we do want it to be this sense. We want it to produce the clamped range, and then we just want to invert it because it's alpha, and so we want to actually know that process. Yeah. I'll have to think about that. There might be a cleaner way to write that, though. Anyway, so let's take a look here. Let me see if I can push this back up again now that we fixed our little bug there. Or I guess we want it actually to be lower, I should say. Right. So those things, are they really that's how low they are? That seems odd to me. I wonder if I've got a bug here or something like this. Because there's the fade top start Z. Essentially, we should always... Ah! Duh. The fade top NZ has to end at the floor height, because otherwise it'll be partially visible. Yeah, okay. Never mind. I'm just being stupid. So that's fine. So let's take a look here. So there it goes, it fades away. As we come up, it comes back in. So we may want that to be a little bit further up where it starts, something like that. So we may actually want this to kind of clip out something more like that. I don't actually know. Something like that. Probably looks a little bit better. I don't understand why we're getting it so early, though. I feel like our alignment with the typical floor height is currently not correct or something like this. So I feel like once we go now and do this thing where we put this into the world as a query call, it'd be nice to start to figure out what the Z values are of some of these entities to figure out why it's doing that the way that it is. What I would like to do here is I would like to potentially allow us to go up another level so we could kind of get a few more in here. But right now we don't really have anything that would allow us to do that because we only ever allow, two things stacked on each other. I wonder if there's some way to quickly hack our little stupid world-making stuff here. I wonder if there's some way to quickly hack that to allow us to do door up multiple times, right? That kind of thing. So it's got random choice, door up, door down. And so I guess the thing here is door up, true, door down, true. So the problem is we don't allow it to freely pick whether it does door up or door down. So I suppose if we did, right, if we were to do that, then what we could do is have, sort of up and down be chosen separately, which I feel like would be a good thing to do. Something, like this. Does this make sense to everyone? Something that allows it to stack as many, keep going up or keep going down, if, as necessary. I also feel like at this point we should have probably allowed it to make rooms that kind of go, that snake back on each other, but yeah. So unfortunately, at this point, I also don't really know. We're never going to necessarily get enough stacked on each other here because it might never create any such thing. So we'd have to kind of also do some stuff that would sort of create the case that we want to test, which at this point, unfortunately, we're not doing. So there's a down. Let's go. We can go down here. Ooh, what happened there? I guess I've ended somewhere where we didn't actually put a room on the bottom. Looks like we just walked down the stairwell into nothing. That doesn't seem like a good idea. Is that because we're always assuming something about where the doors go? Either way, this doesn't really help me. What I need is a couple rooms stacked on top of each other. Not really sure how to do that quickly. So what happens when we create an upstair or a downstair, right? When we add a stair, it does this abs tile -1 or abs tiles thing. And what do we do here? If door direction... Okay, so this is why we didn't actually update the door direction stuff, right? What we actually need to do is say, all right, which direction did we go in Z? Did we go down or did we go up? And then we need to actually subtract whichever one it is. So if it's a door down, right? If it's a door down, that's 3. And if it's a door up, it's 2. So what we need to do is something more like this, right? I believe. And so doors down, do that, and doors up, do this, right? This is some truly lousy code here. But we are not supposed to be working on world building at the moment, and so I feel like we kind of have to, you know, take the good with the bad there. The other thing I could do is, you know, and I might do this. The other thing I might want to do is just make less of these tiles, right? Let's see here. So instead of adding wall, in fact, you know what I'll do right now is I'll only add a wall if tile y mod 2 and tile x mod 2, something like this. Let's take a look. I want to cut down on the number of trees, just because since we don't have an optimized renderer, it kind of helps. All right, so if I walk up here, of course it's hard to tell where the exit is, but yeah. See here. Of course, this means you can kind of just walk through anywhere you want, which I hadn't thought about beforehand. But anyway, all right, so I can walk through here. Let's go ahead out here. Yeah, so what I really need to do is I need to just bias this thing so it will build a few things on top of each other for us. I'm not sure exactly how to do that, because we need to test our sort of lower, our below sort of, our code for things below us. And we don't seem to be, it doesn't seem to have randomly, unfortunately, generated anything that had a lot of things on the same stack. So let's take a look. What can I do to force that to happen? I guess what I could do is say, okay, we could bias it so it just keeps creating doors up and down or something like that. And in order to do that, we just have to have a way of adding a stairwell that doesn't overlap the same stairwell so that you can keep on using them. Although maybe you can just make them all be in the same place, and maybe that just works because of the Z handling. I don't know. Let's try it. It's hard to say. What I could do is say door direction is always going to be equal to 3, so it just always goes down. There's nothing else that will ever happen. That's all that's going to oh my god. What have I done? All right. Well, that's interesting, to say the least. I'm a little confused as to why there are so many levels and what's actually... It looks like they're crossing over some threshold where we've got a flip bug there. So this looks like something that would be good to debug. Although my first question is, how are there so many entities? Do we take all the entities in Z? I thought we were only doing a limited Z slice, so how did all of these entities get in there? That's a bug. Like, somebody's got to fix that. And then the other problem is, why are none of them fading out? So something is not right here. All right. So what's going on? We've got if you're less than fade bottom start Z, right? Which is 2 typical heights down. Then I want to map you in that range where you're going to be subtracted. Let's see. So I feel like that should have worked. So I don't understand why that alpha isn't getting set properly. That said, the more weird thing to me is just why we're getting such a strange amount. We're getting so many that it actually goes down into nothing and flips around, right? You can see how that goes. So we only want like a couple levels here, and I feel like the sim region should never have picked up those guys in the query, right? So if we come in here and you take a look at when it does the chunk Z, min chunk P, you know, it loops over the chunk Z's. How are we getting all of these entities? I don't get it. How are we ever finding entities that are that low and bringing them into the sim region so that they get rendered, right? I don't get it. Excuse me. That makes no sense to me whatsoever. So I want to see what's going on there, because that's just bizarre. That's just super, super, super bizarre. So that's thing 1 to check. Let's just check that now. Let's take a look at begin sim. When we come in here, what does it think the Z range actually is? Am I doing something that would suggest... Oh, and you know what else I got to do? I hate to do this because this will be super slow because we're unoptimized at the moment. But let's turn off that O2 switch so that I can step through the code properly. There we go. Handmade.cpp. All right. So let's take a look at this here. Stepping through. So let's take a look at our our bounds here, right? Our min chunk P. I think we started 10 minutes late today, so we'll go ahead and go till then. Okay. That's a pretty insane range. So I guess we actually did grab a huge number of chunk Z's. Why is our sim region so huge? Is it because of the max entity radius? I think it must be. I think it must be. So what's the max entity velocity? So that's the thing, is we're basically grabbing a huge chunk of Z because of that max entity velocity. So I wonder if that's going to have to be, that's probably going to have to be something that we special case there. Wow, that was a good thing to know, because we had no idea that that was happening. So yeah, so this is a bit of a problem, the updatable bounds thing and the safety margin Z thing, right, of 1. I think we probably want to do a thing here where we're always doing just nothing, right? There's no entity radius stuff that's happening there for now, at least. We'll see if we can get away with that, but that seems more likely to me. All right, so at least now there's a little bit less, but there's still quite a bit. And so I'm wondering if maybe something else here is still too conservative. So let's take a look. We've got the bounds, we've got the safety margin in Z, which is adding up and down, which is just, I don't know if 1.0 is a very sane thing for it. But let's see. Oh, update safety margin is still, again, yeah. Oh no, but we're not using that. We're not using that for Z. So if we don't add anything here, and we only add 1 here, then I feel like our Z-bounds shouldn't be that big. But let's find out what they actually are, because maybe I'm wrong about that. So what's our initial query size? Let's start with that, right? What is the initial size? And so let's check bounds, let's see what it is, min-max, right? So the max z is 15, and the min z is negative 15. Again, that just seems crazy. So what's going on here? Is that something from this? Who is making that decision? Sim bounds expansion. Yeah, so this is just totally bogus again. So basically, we just never were doing anything sensible with z here at all. We clearly just threw that code in, just completely ad hoc, without really thinking about what we want to do. And in terms of sim bounds expansion, I don't think we even want any expansion in z, do we? We just want the level that we're at, and we want the safety margin expansions to handle, we want the sim region to handle that expansion for us, basically. Like, we don't want to add anything to that, I don't think. That would be my guess anyway, right? Of course, that didn't grab anything, which is a little bit odd. So sim bounds expansion, camera bounds in meters, which we also don't know what that actually is. Just a lot of things that were unspecified here. Okay, so that's got no z. So then we have the sim bounds expansion, which we don't really want to do anything with, although later we may want to do we want to simulate upper floors, etc., right? So then when we come in here, we won't add anything here. We will add 1.0 on either end for the safety margin, but I don't actually know. I'm just not sure why that isn't picking anything up. So I wonder if we are we having some kind of a stratification problem in terms of what's included there. So let me go ahead and say that we do the typical floor height in either direction, but that's it, right? And let's see what that gets us, right? So that's a little more sensible, certainly, right? Let me go ahead and we can switch back to our optimized build now. Our O2 build, still a completely unoptimized build, but it's at least compiler not doing crazy stuff. So there we go in terms of that. Our fade in out there is not working properly either. I think I've got like a weird bug in my clamp map to range. I think I just wrote it poorly or something like this. I want to see, I feel like that didn't work the way I expected it to. So let's take a look at what I was doing here. So in clamp map to range, I figure out what the range is by taking the max and min, and then I subtract the min from it and divide by it. I feel like that's the problem right there. We can't check if it's greater than 0 because we want to be able to support negatives. So that was why I was having a problem, right? You saw how that worked, right? That was just me being stupid because I was thinking like, oh, the range has to be greater than 0, but it doesn't have to be greater than 0 because we want to be able to support negative ranges so that the sense still works out right. So that code that we'd written before was actually probably correct, and we were just stupid, right? So remember, I thought this should work and it didn't, right? Always assume there's a bug. Me and Chris Hecker used to say that all the time, especially when we're working with physics. So there's the fade out working properly at the top level now using the correct code ordering that I thought should have worked, and I should have stuck by my guns. And then this guy wants to do starting at the start Z and fading at the end Z, which I think is exactly what we do want him to do. So let's see if we can get that working now properly. It looks like that still just disappears. Now that could be because the sim region isn't picking up someone far enough down, right? And so that, I think, is something we may want to sort of take a look at here. So if we do those camera bounds that we had, right? Where's the camera bounds in meters? What we want to do here is say, well, okay, actually the min, we want to look kind of below where the camera is a little bit. So we want to do like negative 2.0 times typical floor height, right? Or something like that. We want to look maybe 2 floors below, possibly even 3 floors below. I don't know what that number is going to be, right? And then we want to look, maybe one floor above, something like that. And then we can get rid of that expansion thing, because we don't really want to ever expand probably in Z any more than we have to, right? So let's take a look here. That's game state, right? And then we've got same thing here. So that's a little more sensible, although does not look like I did that properly. Somehow, this is correct, right? Camera bounds. Oh no, rectangle center dim. It's not a min-max rectangle. Well, in that case, we have to do this a little bit more jankily, right? But I guess I could just not do it janky. I could still do it right by just doing it this way, right? I can just do it that way. When the camera bound in meters comes back, I'll just set the min z and max z myself here so that I can still set it to -3 floors down and 1 floor up, something like that, right? And that way I don't have to worry about setting it dim-wise. So that seems fine. I'm totally fine with that. All right. So now that we've got this, we're fading the wrong way. And so that is, again, the same problem that we had the first time, I guess, which is, excuse me, which is, again, it's alpha. So even though this is the way that we would want to write it going from the start to the end, since we want it inverted, we would invert it this way, right? And again, I'm not sure that that's the best way to write it. I feel like we want to write it with the 1.0, but I don't know. Hard to say. It does introduce some extra stuff there that doesn't actually need to happen, so it's unclear if that's what we want. But anyway, now we've kind of got it working the way that we wanted it to work, where we can kind of fade in on either side, right? But with the stairwells stacked on top of each other, they're creating sort of that problem where the stairwells, I'm colliding with one, so I can't walk down the other one, if that makes sense. So I want to do a thing where we stagger the stairwell location. Looks like we're just about out of time, so I'm just going to do that. I'm going to stagger that stairwell location, though, here. What I'm going to do is say if abs tile z is even or odd, right? If abs tile z mod 2 and this, right? Put the stairwell there. Or if abs tile z, if not abs tile z mod 2 and tile equals 4 or something. Don't try this at home, kids. So there you can see, again, more of the kind of getting more of that sort of back and forth in that we want. Of course, these annoying fellows are blocking my region. Let's go through here. There we go. Let's see here. Come down. So what we can see too is there's kind of another thing that I haven't talked about. We're not leaving the familiars on the correct levels either. Like we've got a bunch of things now that this uncovers, which is perfect because this is exactly where I wanted to get to. But you can also see that our scaling is not correct, which is another place I wanted to get to, and I wasn't sure when it was going to happen, but you can kind of see it happening now. So you see how we kind of have a weird effect where things seem to move more quickly when they're in the distance in terms of zooming in and out, right? And that's because we haven't actually talked about how to correctly handle perspective in any way, right? And so this uncovers a bunch of things we want to work on, which is great because I feel like this is finally getting us into the point where we can really nail Z down, which is something that was one of probably the biggest things on our to-do list because it affects everything. So yeah, so I'm pretty excited about this. This is quite good. I think this will get us into a good place. So yeah, I feel like we're in good shape here. And again, so what's interesting, just to head off at the pass in case no one answers this question, you notice the familiar and the guy move with us in Z. That's because we don't do ground handling yet. Remember, we haven't done our ground handling project. So I believe what's actually happening is as we move down, because the camera Z level was considered where the ground was, they fall, and as we move the ground down, they basically fall with it, right? So yeah. But anyway, so we're in a great place to start working on all this stuff. This is exactly where I wanted to get to. I'm very happy about this because now we can sort of clean up all of the Z stuff properly. I'm very, very happy about that. We'll get the ground handling working. This gives us great stuff to work on. This kind of opens up all of the problem areas. We're finally in a place where we can solidify them out. And that'll be great. Once we have Z checked off, I think we're in such a great position in terms of like engine unknowns, basically. So I'm going to go ahead and say it's time for the Q&A. Please go ahead and prefix your questions with Q:, so I will see them. And please try to keep them on topic. Okay. Why were some of the trees upside down? So the reason some of the trees were upside down is because we haven't really done perspective yet. And I want to kind of avoid talking about it too much because, like, basically that, like I said, that's one of the things that I wanted to actually talk about for real is how to do that transform. So we have this z fudge value, right? And this z fudge value is just the thing we were using to multiply the x and y positions of people on the screen so that they would appear to get bigger and smaller as they moved closer and further from the camera. But we didn't actually do any work to make sure that it was actually doing proper perspective computation, which means it's just basically a completely bogus hack, right? So what happens, as you can see here, whenever you get something whose z value is high enough, that's negatively high enough, so like negative, once it's negative 1 over 0.0015, this expression will become negative. And once it's negative, multiplying by a negative will flip everything around. It'll basically mirror it, right? And so, well, mirror it's the wrong word. It mirrors it on 2 axes, but it'll flip it around, right? And so basically what you're doing there is, because this is not a real perspective, if this was real perspective, a real perspective thing is actually a divide, right? And so it can never flip because it just, as things get further and further away, they just get smaller and smaller and smaller, right? But we don't have that. We have a crappy multiply thing here, and so they flip. So this to do, figure out exactly how z-based x, y placements would work. To do that, what we need to do is introduce a real perspective divide there, which isn't hard to do, but we have to talk about it on the blackboard first so that everyone understands what I'm doing, if that makes sense. Are the head and body entities off to the side supposed to scale with the main character? So they are moving because the z, so if you remember, right, let's see here. So if you remember how the ground stuff was, we kind of left it. It was the whole reason we went to do the rendering stuff is to kind of get Z straightened out. So do you see how this ground is 0 nonsense is happening at the moment, right? And you kind of get this like thing where we take a spatial partition and get where the ground is and do this sort of other nonsense where we try to figure out like whether or not things were Z supported. I believe what's happening with those entities is that they're actually just being treated, as you kind of move down, I believe they're being treated as if the, I believe they're being treated as if that ground is like coming out from under them, if that makes sense. I don't actually know that that's true. In fact, we could actually test, this code is just so janky and not finished that I'm not actually sure exactly what's happening here, but I can pretty much guarantee you it's a bug. Let me see, PZ equals ground, DP equals 0, HD flag Z supported. Can overlap. So I also don't know, I suspect that it's entirely because of this ground value, and the can overlap, if the mover is not a region and the region is a stairwell, is true. So I'm not 100% certain why they are doing that yet. But I believe it's because they're actually moving with the camera, not, which is, you know, obviously not correct, but it's something that we haven't really finished handling in here. So I'm not sure exactly where that bug is per se, right? Let's think about this for a second, because it's kind of an interesting thing. Ground plus equals entity PZ minus ground entity point. So that's wherever that ground is. Yeah. Is set entity Z supported. Less than or equal to ground. It's going to set them back to where the ground is. So I guess what I'd like to test first, as a way of figuring out exactly what is broken in the sim region thing, is that, where is nsim? I want to see what happens when you do not update the camera Z. So if we do, you know, this sort of thing, right? So if we don't update the camera Z and instead we just move down, right? You can see that they correctly stay up where they were, right? And so again, the reason why I think that's happening is because the ground is currently based on this weird, we don't have a solid notion for what's supposed to be happening with the ground, and I think they just basically fall down to wherever the camera is. They land on the camera's Z height, essentially you could think of it as. So we just need to start, we need to like button up the Z stuff and then we'd be fine, I think. So I think that's really all that's happening. What is Z fighting, and is it something that you have to worry about in a game like this? I can show you what Z fighting is. Z fighting is it's a bit of a large topic, but I'll try to give you what the idea is. And the short answer is no, we don't have to worry about it. But I'll explain to you what it is anyway. Okay. So Z fighting is about depth buffers. If you don't have a depth buffer, you're probably not going to have Z fighting. You could have Z fighting in another way, which I'll touch on briefly, but I'll talk about, this is the one that you're normally going to see. So I'll talk about how you can have it without depth buffers. I'll talk about it without depth buffers in a second, after I give you what the idea is first. So let's talk about with depth buffers. So normally, if you're not doing a 2D game, you're doing a 3D game, and presumably you're doing any kind of typical 3D game which can't perfectly figure out a draw order, then what happens is you rely on a thing called the depth buffer to figure out what is called hidden surface removal, right, in the old days. And what that means is you can imagine if I had something like a very simple object. I just have two cubes. Maybe or you can think of them as something more complicated, like two legs of a character, right? And one of them is closer to the camera than the other, right? And so when I am to draw these cubes, I always want to draw this cube last, right? I want to draw this cube first so that this region, the place where they overlap, is filled by the colors that come from this cube, not this cube, right? So if this is A and this is B, the correct draw order is B, then A, right? But the problem is in 3 dimensions, it's hard to know that, because these could be complex objects that, you know, don't have a necessary sort order. Like maybe part of this object is behind this object. It's a curved thing that also exists kind of behind here. So then there's no draw. It's like draw this part of A and then this part of A and B. Draw this part of A, then this part of B, then this part of A, or something like that to get the draw order right. You know what I'm saying? It gets very complicated. To give you a better, maybe a better illustration, suppose that I had a donut, right? And then a cube inside a donut, right? So that's the drawing thing, and we're looking at it from here. So if we're doing that, we've got sort of like a cube-like shape in the middle. We've got this sort of donut shape coming around it, like so, and then maybe the cube sticks out the bottom a little bit as well, right? And so if you think about this, the draw order, if this is A and this is B, there is no draw order because this bottom part, this back part, this part, right, of A, it needs to be this part first, then this thing, right, this second, and then this part third, right, in order to make sure that they occlude each other properly so that you don't see things that you shouldn't see, right? So hopefully that just gives you some idea of it's complicated if you want to figure out a sort order. So what you typically do in 3D graphics is you don't try to solve this problem. Instead, instead of solving it per object, which is kind of what we're talking about here, which would require you to break objects up into pieces and sort the pieces and stuff like that, you handle it per pixel, right? Because you know that every pixel, right, for any individual pixel, we know there is one sort order, like A, then B, then whatever, right? And furthermore, at each pixel, we can do something which makes it so that we don't have to draw them in order. We just need to know when we come to a particular thing, we just need to know whether it should replace the thing that was there or not, right? And so if you think about it, let's say that we have a draw order of B then A. Well, if we look at it at a pixel basis, right? In fact, let's go back to here. So we've got A is our tube and B is our cube thing, right? So we've got a draw order of A, B, right? If we take a pixel that's right here, right? Then what's going to happen is A is going to draw and it's going to fill it in, right? So, we have what's the pixel here, right? What's happening to the pixel. And this is in an A-B draw order. And then we have the pixel here in the B-A draw order. So whichever way the app submits them. If it draws A, then B, what's going to happen is A is going to be there, then it, right? Then it draws B. I shouldn't do this way. Sorry, that's not what I should do. I should do this first and then second, right? So the first thing that's drawn is A. So we look at A and we get an A, right? The second thing that's drawn is B. And now what we want to do is know that we should not replace B. We should not replace A with B because B is behind A, right? We want to stay with A. And then in the other draw order, what we would do is we draw B first. And then when A comes, we do want to replace B with A for this pixel, right? Does that make sense? And the way that we do that is with every pixel, we store a depth information. That's what a depth buffer is. And the depth information is basically saying how far away, right, was the current occupant of the pixel, right? So what we do is we draw A in here and we say, oh, A was, 1.2 meters away from the guy or whatever, right? Then we draw B in here and we say, well, B is 3 meters away from the guy. And it's like, oh, well, you know what? We don't actually want to do that because this is a closer value. So we keep the one that we had. Whereas here we say, oh, it's 3 meters away. Then we draw A and we go, oh, okay, he's 1.2 meters away. That's closer. So a depth buffer is basically a thing that remembers how far away the thing was that filled the pixel we're on so that we know whether to replace it with a new pixel when it comes in. And you can see why this works now for A on top of itself as well, right? If I have, A is a tube, right? But I'm looking at it so obliquely that the tube kind of obscures itself, right? Well, it doesn't matter what's in here. It's whatever part of A, if there's polygons back here and polygons in here and they're drawing on top of each other. All we need to know is what the color value would be here and what the depth value would be here. We compare that with what exists and we replace the color value if the depth value is further away, right? That's all we have to do. So hopefully, does that make some sense? I hope that makes some sense to people. It's a very simple scheme. It's just remember how far away things are so we know whether to replace it with new things that come in, okay? What z-fighting is when this computation is imprecise, okay? Because it would always work. What I just said would always work, right? There's no reason that would ever not work, right? In conceptual math. But math is not done conceptually in a computer. It's done with floating point values. And the problem is, what happens when two surfaces are sufficiently far from the camera such that the floating point precision that is representing their distance is no longer able to distinguish between the two, right? And remember we talked about floating point precision. We talked about it many times on the stream. So, okay, we've got a z value, let's say, right? And we've got two things that are very close together, right? They're so close together right now that in fact there's just a small bit of mantissa, right? Let's say there's like 2 bits or something of mantissa that's actually distinguishing between the two of these. As the camera moves further away, so these objects kind of move further back, right? It becomes only 1 bit that's distinguishing them, and eventually it's 0 bits. And when it becomes 0 bits, these are both essentially mapping to the same z distance from the camera in floating point, right? And to be fair, does this really happen often in floating point? Not so much. What's actually happening here oftentimes is it's not a full 32-bit floating point value when you get z fighting. It's oftentimes like a 16-bit approximated z value or something on the GPU, right? So again, don't think IEEE float, just think whatever the GPU is using to represent depth, which may be much less precise than a 32-bit value, for example. Okay, so if that precision collapses to 0 bits, what happens is you no longer know the difference between between the pixels A and B that are coming in, right? And so what will happen is whichever one of them happened to be drawn first might actually be the one that stays there, right? And you get a random, you sort of get whatever the draw order is, will pick who draws, right? And what that would do is that would basically show, you know, if we were looking at two plates that were right on top of each other, A and B, you'd basically see A if A were drawn first, or you'd see B if B were drawn first, or depending on whatever the comparison scheme is, the GPU actually lets you pick, you'd see one or the other, right? So that's one form of Z fighting, which is if A is actually supposed to be behind B, but it's drawn first, it'll now start showing up in front of B, just at the time when it moves behind, right? That's one for it. Things get much worse, however, when it's slanty like this, right? When it's slanted like that, then what happens is the floating point precision may oscillate so that it can tell that A is behind B, right? Here's A, here's B. As this gets, these are different Z depths from the camera, right? Because these are slanted. As it steps these, it may find that it can distinguish between them at certain places because the floating point math works out to have 1 bit difference between them, but on another one it maps to 0 bits, right? Just because of the way it collapses, in, out, in, out. And then what you get is this horrible stippling pattern, depending on the angle of the things, where B shows in front as it should properly, but then A peeks through in like a pixely banded pattern, depending on the sort of angle and the iteration on the GPU, right? That's the worst kind of Z fighting, very bad, right? And you see this nasty pixely pattern, right? And so that's Z fighting. It's when the precision breaks down so that it can no longer tell the difference. And there's a number of places that that can come from, but hopefully I've given you some examples of how it's kind of easy to understand. Stream is over, so I'll say one more thing. Without depth buffers, and you're talking about the Z fighting, we could still have a Z fighting problem in Handmade Hero even though we're not using a depth buffer, and that's because we will be sorting our things, right? And so we could still have this problem, the original problem here. Whereas if we had set our things up poorly such that our Z coordinates had gotten so large that the mantissa could no longer distinguish between the two of them, we might sort the two things incorrectly all of a sudden. Like A is supposed to be on top of B, but we drew B first, right? And that's still a form of Z fighting. It's just not the same as the kind on the GPU where, since things are usually angled and doing weird things, you get a stipple pattern because the who's in front, who it thinks is in front is changing. We would not have that problem, probably. But what we would have is we'd have the sort order when it got out to that point where it collapses 0 bits. Now it would sort them differently, potentially, because it would just use whoever came first or something, whereas before it was actually doing the sort. So we still could have that. Now, we won't have that because our Z values will never be that large. We will never have that kind of a problem, and we're doing it in full floating point, which typically GPUs at full floating point Z buffers don't have that problem because 32-bit is totally fine for doing any of the Z usually that you want to do. So typically, what you see Z fighting wise is on modern things, on modern high-end GPUs, the kind of Z fighting that you'd see is not really the same kind of thing that I'm talking about. It'd be more like shadow map problems where you're doing back transforms that lose precision because of the fact that they don't map one-to-one on the pixels. That's a whole separate thing. So this kind of Z fighting is more common in older games than newer games, whereas newer games still have things that you could consider to sort of be Z fighting, but they're really they're really not the same thing. They're because things are getting mapped in a non-one-to-one pixel way, which is a separate thing, and I don't have time to talk about that now, but hopefully that's good. Hopefully that is, yeah. Hopefully that clears that up. So, all right, stream is over. It looks like there's really no more questions anyway, so that's good. And so hopefully everyone is a happy camper today. Everyone has had their dose of Z and alpha. And so we've got plenty of stuff. This opens up a huge set of things to work on. So really excited about that. Tomorrow we'll just tackle some of that. Maybe we'll get the ground in there. Maybe we'll work on the perspective transform. Who knows what we'll do, but we'll do something. We've got tons of a huge big front open up for us now, so that's good. And that's what we will go do. So thank you everyone for joining me for another episode of Handmade Hero. It has been a pleasure coding with you as always. It's always good when you can push forward into a new problem area. I think that's kind of where we're at right now. We're getting there. So that's good. Thanks very much for joining me. And again, if you're interested in the series, you like the series, and this is your first time here, we're here every day, 5 p.m. Pacific Standard Time, here on Twitch. We'd love to see you come back. It's always good to see new faces. If you want to follow along at home with the source code, we also do provide the source code. If you pre-order the game, you can download the source code as well, which is a good way to play around and just have fun with it. We also have a Patreon if you want to support the video series, if you want to subscribe to the video series, and that's just as a nice thing to do for us. It's always very appreciated. You can do that there. We have a forum site you can go to where you can ask questions, and you can also take advantage of some stuff the community's done, annotated episode guide, ports to Mac and Linux, that sort of stuff. And we also have a tweet bot that will tweet the schedule at you. So if you want to catch the stream live and you're not sure what the schedule is for the day or that sort of stuff, check out the tweet bot. You can either subscribe or just check him out and see, because it's usually got the day's schedule on there. And it doesn't really tweet anything else except once in a blue moon. So that's a good place to check that out. So thanks everyone for joining me. And we will see you tomorrow for the last stream of this week, for the Friday stream. Hope to see you all here for some Friday fun. If not, have a good weekend, and I will see you on Monday. Either way, take it easy, everyone.